note that what they would show is some detective just tasting it. They don't really do that. Yeah, because it turns out that if you think about it a little bit, most solids are either white or black. And then the majority are going to be white. So you have, sugar and salt and flour and baking soda and, baking powder and TSP and all those things are just white solids. So, you don't want to be tasting all of them. You don't be just tasting whatever you find on the street. Okay, so anyway, let's take a look at this solvent. That's what we did when we were kids, because after Halloween, you're walking down the street and you saw candy in the middle of the street and you pick it up and eat it. And like I have 2 dogs and I got to keep my dogs from eating, eating stuff they shouldn't be eating. So we're not kids or dogs. We gotta be more sensible. Okay, here's 13.84. Okay, so let's see. So they have 0.5 grams of the substance. And then you have 8 grams. Okay, so 8.5 dissolved and 8.0 grams of benzene. And then the solution freezes at 3.9 degrees. Okay, so the freezing point of the solution is 3.9 degrees. Can the chemist conclude that the compound is cocaine? So another way of asking it is the solute cocaine, and cocaine has a chemical form of C17 H21 NO4. And then what assumptions are made in the analysis? Okay, so what would be your problem-solving method to solve this problem?
Identify the solvent and solute.
Rolando, you're going to say it again?
So you can identify that your white substance is a solute, right?
Yeah, so this 5 grams is a solute. And then the solvent is the benzene, so this is the solvent. Now what equation will we use to solve this problem?
Freezing point depression. Freezing point
Yeah, so you want to use freezing point depression. So you use this equation, delta TF is equal to I times KF times M. Now you're given the freezing point of the solution. What else do you need to know about the variables in this equation? Yeah, so do we know what KF is for benzene? Okay, so this is our solvent, so KF, we can look that up in table 13.2 in the textbook. What else do we need to know?
Molality?
Yeah, we need to know the molality. Can we determine the molality of the solution?
Yeah.
Okay, now note that molality depends on the solute, so the molality is the moles of solute per kilogram of solvent. So are we given any of those pieces of information?
Yes. Wait, no.
Well, we would have to find out, so you have to write a chemical equation.
Yeah, so the kilogram of the solvent, the benzene of the solvent, so are we given this information?
Yes.
Yes, we know that. That's from here. Do we know the moles of solute? No. We know the mass. We know 0.5 grams, but we don't know what the molar mass is. And that's what we try to find. Okay, so again, we know the moles, but we don't know what the molar mass is, so we can find what the molar mass is going to be. Now for delta TF, that's equal to, let's see, that's equal to the freezing point of the pure solvent minus the freezing point of the solution. So we know what the freezing point of the solution is, 3.9 degrees. Do we know what the freezing point of the pure solvent is? Yeah, we can look that up in table, and we find the KF, we find that in table 13.2. So if you do that, so table 13.2 is on page 450. So for benzene, the freezing point of benzene is 5.5 degrees. Okay, so the freezing point of benzene 5.5 degrees. And the KF for benzene is 5.12. Okay, so you have enough information to figure out whether this white substance is cocaine.
I is going to be 1.
And actually, that you're answering, Rolando, you're asking that second part of that question, which was what assumptions are made in the analysis? Yeah, because based on this chemical formula, what type of compound is C17H21NO4? This is ionic or molecular? Yeah, so this is a molecular compound. That means I equals 1.
Good.